The dragonfly looks light and fragile, but the way it hunts challenges everything its size suggests. It sees movement, corrects its path in midair, and turns a few seconds into a decisive advantage. The true secret of this predator appears long before there is any visible sign of wings. Before taking over the sky, this insect already lives as a predator hidden beneath the water. Its life between water and sky reveals why the dragonfly plays such an important role in nature. It hunts, feeds other animals, and connects environments that may seem completely separate at first. Reducing its role to mosquitoes leaves almost all of its ecological importance out of the story. Its efficiency appears when vision, flight, and transformation begin working as a single system. Behind those delicate wings is a body designed to detect movement and react incredibly fast. The first clue lies in how it reads space and anticipates the path of a moving target. Most of the head is dominated by eyes designed to register rapid changes in the surroundings. This gives the dragonfly the ability to distinguish a tiny target among several stimuli and react before it can move away. This visual ability works together with extremely fast nervous responses. Instead of simply chasing prey, it adjusts its path while flying and turns small course corrections into a decisive advantage during capture. Hunting also depends on anticipation. The dragonfly does not need to follow every turn made by its prey. It estimates where the encounter may happen and directs its own flight there, saving movement and increasing its chance of success. This combination of vision, reaction, and control helps explain why some observations have recorded capture rates close to 95%. The number can vary, but it shows how remarkably precise this predator can be. None of these abilities works alone. What makes the dragonfly so efficient is the combination of perception, body control, and the ability to correct decisions in fractions of a second, almost as if every flight were a live calculation. But before any maneuver in the sky, there is a silent predatory phase hidden beneath the water. During its youth, the dragonfly lives as a nymph in rivers, lakes, wetlands, and other aquatic habitats. Its body looks very different from the colorful adult, because at this stage it stays hidden among plants, rocks, and sediment, waiting for the right opportunity. Its strategy favors patience and opportunity. Targets can include aquatic larvae, small invertebrates, and even tadpoles. Instead of traveling long distances after them, the nymph waits for prey to come close and turns a few movements into a rapid attack. One of the most unusual features of this stage is found near the mouth. The so-called mask is an extendable structure that stays folded underneath and shoots forward to seize prey. The strike happens so quickly that the target often has almost no time to react. This completely changes the way we see the dragonfly. By the time the adult appears flying above the water, its life as a predator has already been underway for a long time. Before the sky, it was already controlling small organisms in the aquatic environment. The nymph also has an unusual way of breathing. It moves water internally through the rear portion of its body. When it needs to escape, it can force that water out, creating a burst of propulsion that quickly drives it through the aquatic environment. This feature shows that efficiency does not mean constant speed. The nymph can remain almost motionless for long periods and react explosively when necessary. It combines energy conservation, ambush tactics, and acceleration at exactly the right moment. After an underwater period that varies by species and local conditions, the transition begins. The nymph finds a firm support above the waterline, such as vegetation or rock, anchors itself, and moves directly toward adulthood without going through a pupal stage. At that moment, the old skin splits and the new body emerges in a vulnerable state. The wings begin small and flexible, needing time to expand, take shape, and harden. For a while, the future aerial hunter can barely use its greatest defenses. Only after the wings become firm does the situation change completely. The predator that once hunted among underwater sediment begins moving through the air, applying the same advantage of perception, detect movement, choose a path, and reach the target efficiently. The four wings can be controlled with remarkable independence, allowing sharp turns, hovering, sudden acceleration, and even backward flight. This mobility helps the dragonfly capture prey, defend territory, and find mates during its adult stage. That is why saying dragonflies exist only to reduce mosquito populations leaves out most of the story. They act as predators in two very different stages of life and participate in ecological relationships that connect water and air throughout their life cycle. This is where their best-known role appears, helping limit populations of small insects. Adults remove mosquitoes, flies, and many other small insects from the air. Their young forms attack aquatic organisms, including mosquito larvae. The effect takes place at different stages of life and reaches both aquatic and terrestrial environments. That does not make the dragonfly a household solution for mosquitoes. Their abundance depends on water, climate, food, shelter, and breeding sites. Dragonflies contribute to natural control, but they cannot eliminate the problem on their own. Their role makes more sense when viewed as part of a network. By capturing smaller prey, they influence populations. By becoming food for fish, birds, amphibians, and other animals, they also transfer energy across different levels of the food web. This double position, as both hunter and prey, makes the dragonfly an ecological connector. It takes energy from smaller organisms and can later transfer that energy to larger predators, linking nearby aquatic and terrestrial environments. Its connection to water reveals another important role. Because the young stage depends directly on rivers, ponds, wetlands, and flooded areas, changes in these environments can affect both the number and diversity of dragonflies found in a region. Finding a diverse dragonfly community can suggest that an area still provides key resources such as breeding habitat, shelter, food, and suitable water. This signal must be interpreted with other information, but it still has value in environmental studies. Major changes in the number or variety of these insects can also accompany habitat degradation, including pollution, removal of shoreline vegetation, or physical changes to the water. For that reason, researchers include dragonflies in ecological assessments. Dragonflies alone do not function as a perfect measure of environmental health. Their value appears when included in broader assessments because their life cycle requires suitable underwater conditions and later enough terrestrial and aerial space for adults. This movement between two worlds helps explain their importance. The dragonfly grows underwater, completely transforms its body, and continues putting pressure on other species after entering the air, maintaining a predatory role throughout its life cycle. There is also an impressive historical dimension. Ancient lineages related to modern dragonflies appeared long before humans and survived enormous environmental changes. This shows how successful this general body plan has remained over time. The animal we see today is not frozen in an ancient form. It represents a lineage transformed over vast periods, in which complex eyes, controlled flight, and aquatic development still combine to create an extremely effective survival strategy. That is how such a small insect ends up performing roles far greater than its appearance suggests. The adult patrolling a lake carries the result of a radical transformation. Its journey began underwater, in a world of waiting and ambush, and ended with a delicate emergence that turned an aquatic predator into a specialist of the open air. In the air, the logic remains sophisticated. The adult patrols areas, detects movement, and uses rapid maneuvers to intercept targets. Its body was not built simply to fly beautifully. Every feature is tied directly to survival, hunting, and reproduction. Anticipation reduces the need for long pursuits. By estimating the prey's likely path, the dragonfly avoids unnecessary movement and adjusts its course during approach. Flight becomes a continuous process of real-time decision-making. Its precision comes from combining fast vision, movement prediction, and constant course correction. Rather than depending on a long chase, the dragonfly tries to turn a few brief moments into an efficient and highly controlled interception. All that precision still has limits. Dragonflies can also become food for fish, birds, spiders, amphibians, and other hunters. What stands out is not invincibility, but the enormous performance they extract from a small, agile, highly responsive body. There is another less obvious consequence when the nymph leaves the water and becomes an adult. Matter accumulated in the aquatic environment begins moving onto land. That energy can later be transferred to predators living outside the water. When the adult leaves the water, it helps transport resources between ecosystems. What was accumulated during underwater growth can become food for terrestrial predators, while the dragonfly itself continues capturing prey and entering new feeding relationships. That is why the question of what dragonflies are for does not end with mosquito control. They occupy several links in the food web, help reveal conditions in aquatic habitats, and carry ecological effects from one environment into another throughout their lives. Even a dragonfly resting on a leaf hides this level of engineering. The body that looks calm for a few seconds was shaped to detect movement, react quickly, and use energy efficiently without depending on brute strength or large size. Once airborne again, it can hover, change direction, accelerate, or correct its path during an attack. This versatility is not just a spectacle, it expands its options for hunting, defending space, and finding mates in an environment filled with constant motion. In the end, the beauty of the wings is only the most visible part. What truly stands out is the combination of strategies that allows the dragonfly to survive in two stages, hunt in two environments, and participate in relationships that support ecological balance. Enjoyed discovering what lies behind this flight? Subscribe and explore more stories from nature. In nature, usefulness does not mean existing to meet a human need. The importance of the dragonfly comes from its relationships. It reduces small prey, feeds other animals, and participates in processes that connect aquatic and terrestrial environments. Its efficiency appears when several abilities work together. Eyes tuned to movement, rapid nervous responses, wings with remarkable maneuverability, and trajectory prediction. In water, the young insect follows another strategy based on patience and sudden attack. The change from nymph to adult seems extreme, but there is a clear continuity. In both stages, the dragonfly depends on recognizing opportunities, avoiding wasted energy, and reacting at the right moment, even when the environment changes completely. That is why dragonflies can help reduce mosquito populations without solving the problem alone. They add predation pressure at different stages of insect development, while climate, shelter, water, and reproduction continue influencing the final result. In an area with water, their presence can tell a much larger story. It may reflect available prey, vegetation, breeding sites, and habitat conditions, while also revealing how aquatic processes continue influencing life on land. The long history of this lineage does not mean it stopped changing. The modern animal is the result of continuous evolution, and the combination of sharp perception, flight control, and aquatic development remains effective against very different challenges. The secret behind this performance is not exceptional strength or endurance. It comes from detecting change, predicting movement, controlling the body with precision, and undergoing a transformation that gives access to two very different environments. The next time a dragonfly appears near the water, look beyond the wings. That body combines an aquatic hunter, an aerial specialist, and a link in the food web that influences other species while silently connecting different parts of the ecosystem.